All right, so I will start from the basics. What is manufacturing? Um, so this may sound very obvious, but generally, manufacturing is the when you're translating a design you have into something physical. But that is not always a straightforward scenario. You have many components that are interrelated. And that's, I think, the key to realizing and coming up with a well-manufactured product is that you realize that your design, once validated and tested, is related to what material you're selecting, and that is related to fabrication. And yeah, basically each one of them are related to each other. So you can't just make considerations on one while not thinking of the others. So on that note, that's just kind of a disclaimer. This specific manufacturing session, we're going to be talking about material selection. For the design, there's other like a CAD SolidWorks session. This one will be on material selection, and the next manufacturing PDH will be on fabrication. So letting you know that now. And this semester specifically, we've made a change requiring reflections. Um, so keeping that in mind, I came up with a good reflection prompt at the beginning, so you guys can kind of start thinking what to reflect about, what to write about, given the information that you see. So for this particular PDH, this is the suggested reflection. You can reflect about whatever, but it would help for you to think from the context of your EPICS project. First of all, when would manufacturing be needed in your project? And also, how does your design affect manufacturing and vice versa, as I just mentioned? And then um, further on to the considerations, what considerations do you have to make in material selection for whatever product or design that you're making? And this specifically ties into this skill session on material selection. So that's something to keep in mind, and you can reflect on it once this is over. So as a high-level overview, um, there's two things to consider. Well, there's many, but then two things to keep in mind is that there's various properties that can be broken down into three categories. You have design-centered properties, environmental properties, and fabrication properties, each of which I will go over. But I think this is a good framework to make your decisions on how you're going to select your materials. Is consider each of these areas: design-centered, environmental, fabrication, and then select your material. Material classes involved metals. You have metals, polymers, ceramics, composites. Metals, what typically is readily available for you guys to machine within the EPICS shop is aluminum. Uh, for the most part, aluminum. Sometimes you have copper. Um, Polymers. Acrylic is a big one nowadays, especially with you see a lot of acrylic with like the COVID shields and things of that nature. Ceramics. We rarely use ceramics in EPICS. Even within Purdue, I haven't seen much. But then you have composites like carbon fiber, which I'll go through. Those are more high performance special materials. Before I mention anything going forward, just one thing to keep in mind is there are going to be the situations where even after going through this presentation, you're not going to be sure um, what considerations to make, and especially when you're machining, uh, specifically about the properties of the material and how to machine. So again, always when in doubt, ask your machinist. In this case, it would be the TA, undergrad TA, or grad TA, or the lab manager, Jorge. So our three high-level property classes are design-centered properties, which are meant to satisfy like the functional requirements of your engineering design. And then you have environmental properties. These are constrained based on the operating environment of your product, meaning when your product is being used, what are the conditions around it that would lead to your material selection? And then finally, we have the actual fabrication properties. So this is what you consider when you're in the phase of machining. You consider the costs of machining, the available machining methods you have, the manufacturing quality quantity that is going to be available to you. And here are some of the very valuable resources if you are in your project going to machine. MatWeb is a website where you can find out all the material properties, especially those that are machinable and those that you may be considering for your designs. Like Mastercar is a standard, again, popular website. This is where you have, you can easily get access to raw materials, whether it's aluminum or acrylic or carbon fiber, whatever. And then for further information about like if you're working with chemicals, you have this really good website on chemical resistance for each of the material properties. And so touching back on the different considerations. So I mentioned here, right? So we have design-centered properties. In design-centered properties, you can further break down what you're considering, or you have to think about the mechanical properties of the material you're picking, as well as the thermal properties, electrical, and chemical properties. I know this may sound like it's a lot of things to consider. And in a lot of situations, you don't have to consider all of them. Depending on your design, one may be more important than the other. For example, Elise is, I believe, Imagination Station has an enclosure set up for their exhibit to keep that Mars rover within enclosure. For that particular scenario, the mechanical properties of the material selected for the enclosure would be very relevant. However, the chemical properties may not necessarily be need to be considered heavily, because yeah, we have children interacting with the enclosure, but not necessarily any. It's not going to come in contact with water or be be in contact with other chemicals that can affect the performance. So going to mechanical properties. Under mechanical properties, these are typically the three things that you consider before picking your material. Is the Young's modulus, which essentially is the elasticity of the material. So the relationship between the deformation of the material and then the power or force that is needed to deform it. Density is also something to consider. For example, if you're making a toy that requires you to select a material that is light, yet sturdy and strong, such that when a kid is able to pick up the toy, but then if the kid throws the toy around, nothing's going to happen to it, or it's not going to break. And then yield strength is the maximum stress that a material can hold before essentially breaking. So again, all of these properties are you can easily look up for various different materials. And for those of you that may be taking MSCE 230 or even within your majors, you may come across this chart. For all different materials, you have the sort of relationship between stress and strain. Generally, you have the elastic region where there's a linear relationship between the stress and strain, and then at a certain point, it becomes the properties of the materials start changing. So you go into plastic deformation. So if you've elongated or deformed a material more than the limit, it's not going to return back to its original shape. So specifically, that's kind of like underlying knowledge that will inform you, but I don't think it's 100% necessarily to always be thinking about this. This is something that is useful. So I went over the mechanical properties, and typically that's probably the first thing that comes to mind whenever you're picking a material to machine. But then another important thing to consider, depending on the used case, again, as I say, it's all about the use case. What scenario is your product going to be used in? Electromagnetic property is something that always you have to consider. Electrical conductivity. If there may be not a lot of situations, but sometimes having a if you're near any sort of outlets or even ionized solutions, selecting a material which is highly conductive is not optimal for you, and it could be dangerous. So electrical conductivity is something to take a look at. And again, dielectric strength is one more electromagnetic property. So when there's an electric field or some sort of charge, static charge even, around a material, it can, at a certain threshold, it starts conducting electricity. So this, for example, in mobile phones, when they're picking out the metals, there's they really take a look at the dielectric strength of the metal to ensure that when the mobile phone is near any sort of electric field, it does not short circuit the device. So if you're making more sensitive devices, dielectric strength is something to consider. Magnetic permeability, hysteresis is basically if your magnetism is going to get affected by the machining process. And then I should not have put transparency on this slide, but it's something to consider later onwards. And this may be something you may consider more often. It's thermal conductivity. A prime example to consider this would be a situation where you're making, one of the teams was making playground equipment. Selecting a like stainless steel, for example, it's a material which has very high thermal conductivity, would be bad in this situation because the playground is going to be outside, and when it's very hot and kids sit on the playground toys or whatever they called, a swing set, it's going to burn the kid. So in that sort of situation, you would consider thermal conductivity. Thermal diffusivity is proportional to thermal conductivity, but it's relative to the density of the material. So this is another thing to look up. I know I'm like just throwing a lot of things to consider, but then again, the purpose of this skill session is to kind of show you what are the different considerations to make, and then based on the context of your project, you have to go through and decide which one of these things am I supposed to consider when I'm picking out the materials for manufacturing my product. And yes, like I mentioned, this is another, so we went through design-centered properties, and now environment properties is, this is basically the environment that once manufactured, your product is going to find itself in. Again, operating temperature, um, chemical resistance, radiation resistance. I've had a team which used PVC to make a device that was sitting outside in the sun. And PVC gets brittle and it loses its properties on under UV. It's meant to be indoors. So again, that's something to keep in mind is, are you in a place where it's going to be hit by a lot of radiation, whether it's sunlight, infrared, all those things have to be considered when you're picking out a material. Another thing is obviously appearance. Does it have to look shiny? Does it have to be transparent? There's actually not too many options available when you're trying to have something built that is transparent. But acrylic is something that is readily accessible, and we have a laser cutter in EPICS. So you can easily have that machine. So if there's anything transparent that you would have to manufacture, keep in mind acrylic is always an option. And also sustainability, right? In addition to, very few people think about this. In addition to building your product and having it be used, you always have to keep in mind that at the end of the day, your product is going to break down and it's going to reach its, like, the end of its life cycle. And at that point, it has to be discarded. So if you pick material that that does not break down easily, things that cannot be disposed easily, there's going to be a cost to it. It may not be a direct cost that you're going to incur on your project, but then there will be an environmental cost. So that is something that few people keep in mind, and I think it's a very responsible consideration to make. And I think it's something that needs to be made more so nowadays. So again, that is something you guys can reflect on. Like, the materials that you're selecting in your project, are they sustainable? Are they going to be degradable? Is there a cost to throwing them away once it's broken down? That's a great thing to reflect on. And after, generally, you also have to, after all that I've said, you also have to consider the fabrication properties. In this case, I'm going to start out by saying that casting, molding, forging. I'm not sure if you guys are familiar with casting and molding, but a lot of the plastic that you see in appliances, a lot of it is molded. And that sort of a thing, making a mold is expensive, but the whole purpose is to enable mass manufacturing. So I don't, in EPICS, I don't see a situation where you're going to have to mass manufacture a product. Generally, it's one product or the other. And molding, making a mold is very expensive, and you cannot do it on campus. However, if you are coming up with a product where you're gonna have to come up with a lot, or you're gonna hand over the manufacturing process to the project partner or something of that nature, then molding is an option. Yeah, again, there's a trade-off one needs to keep in mind between like rapid prototyping and then like how well your build quality is. So a lot of what happens in EPICS is rapid prototyping. Um, the whole setup is designed for that. Um, so a lot, you guys are gonna be in like the prototyping phase, and then you're going to be in the uh, ones that has been proven. You generally use cheaper materials to prototype, and then you build out your actual product. So one thing to keep in mind is when you're building your actual product, you don't have to be forced to to use EPIC's machining services, or even within Purdue, you have access to other machining services. So EPICS has specifically the um, priority project program. So if for those of you whose projects are, you verified your design, you have some sort of prototype, but then you're in a situation where you need some professional quality manufacturing, then I would consider you, or I would suggest you apply to the priority project program. And that way you get kind of, if you want to do more high quality builds, you can have access to vendors that EPICS has to do the machining. So that's something to keep in mind. And finally, or not finally, another thing to keep in mind with fabrication is that the machinability of the material you pick directly impacts the cost. Generally, aluminum is known to have high machinability. Hence, you see it in so many EPICS projects. You see slabs of aluminum lying around at the bottom in the basement, the shop. But then you don't see a lot of titanium. Titanium is not, it's a great material, don't get me wrong, but it's not very machinable, and you don't find, it's very expensive too. Bro, and a good reason why is because it's not machinable. Um, and then finally, I don't think you guys will ever encounter or consider a hazardous material, but um, if a material that you're considering is hazardous, it's generally not allowed, whether in EPICS or in the other machine resources you have, like the BIDC. These are like beryllium, magnesium, and plastics that have embedded glass, so glass reinforced plastics. So yeah, again, when in doubt, ask the machinist, TA, or lab manager. And so now I've kind of went on a spiel about all the different properties that you're going to be considering. Um, so let's get into the options you have as far as what materials you can pick. I'll start with metals, and then I'll work my way into polymers, ceramics, and whatnot. So metals, I will start with aluminum because that is the most common material and the most accessible material. Anytime you're considering a metal to be a part of your design, it's probably one of the first things to consider. It has a high strength to weight ratio. Um, it does not fatigue very easily. It's you have so many different alloys with each of them with different levels of toughness. And then most of them are resistant to air, humidity, solvents. They're generally not too expensive. Depends on the alloy that you select. And also they're easy to work with. They're widely available. By widely available, I mean there's also random slabs of aluminum sitting downstairs in the basement. So if there's some small piece of metal or some small part that you're trying to machine, keep in mind that there's aluminum sitting downstairs. If it's small enough, you can probably just pick it up. The general options that you have as far as the alloys are concerned, for very good machinability, 6061 is the standard. Same goes with welding. And then you have 2024 7075. The difference is going to lie in the properties that I just mentioned. So that's something for you guys to take into consideration, is which alloy to pick, and you can easily find those properties. And in McMaster-Carr, you can also order any of these. And then I put this second, carbon and steel alloy. Though these are they're very robust materials, like they don't easily break due to mechanical reasons. They're harder to machine. So one thing to keep in mind with steel carbon alloys is that the properties can be variable because a lot of them are heat treated. And one thing to note, toughness and yield strength are inversely proportional. Toughness is like how resistant is it to change, and yield strength is how much does it take to break it. And another thing I've put a lot of bullets here, but just keep in mind that steel alloys, they're hard to machine, but then they're very weldable. You can easily weld steel. So anytime you're considering more complex, then steel may be an option, where compounded parts I meant, where you may have to make different joints. If you're making a car, that may be something to consider. So quickly going through the steel alloys, 1018 is the standard general purpose alloy. That's the most commonly found, that's cheapest that you find. It's low strength. And then you have 4140, which is higher strength, heat treatable. And then you have a whole class of steel called tool steels, which they have a wide range of properties, but they're more difficult to machine or form. And you have merging steels, which they're more of like the high end. They're very expensive. So I don't think there's any EPICS team which would consider those. And we have stainless steel. Anytime you've come across stainless steel, or a lot of times that you've come across stainless steel, it's probably with your silverware or like your kitchen cutlery. And the reason, because they're known for stainless steel relative to regular steel, is known for its corrosion resistance. If you put when you put your silverware in the sink with soap and water, all kinds of stuff, you don't see any rust. However, if you take a carbon steel alloy, drop it in your sink, you're gonna see a ring of rust around it. This is very difficult to machine, just as steel usually is. But then it's corrosion resistant, and as it goes with steel, it's easy to weld. It looks a little more shiny. The others, like regular steel, steel alloys, is like darker. So you stainless steel more shiny. So the 304 alloy is the most common. If you want extreme corrosion resistance, 316 is an option. And then there's a high strength option as well. So this is 440C. I know these numbers don't mean anything to you if I'm just throwing them at you. But if at some point you need reference as to what alloys to even consider, you can probably come back to these slides and kind of use Google from there on. Finally, I would like to, the final class of metals you can consider as copper. I have seen only once where someone machined copper downstairs. So you have brass and bronze. Those are the two standard copper alloys. Um, yeah, they're both machinable. So I don't necessarily know of a situation where you would use brass or bronze as opposed to aluminum. So that's a little rare. And then you have titanium. Um, Titanium is so strong. Like even the machinery that cuts aluminum is made of titanium. Um, so yeah, this is an example. Whenever you see people with metal teeth, it's generally titanium. I've been mentioning weldability. So most steel and aluminum are generally weldable. So aluminum depends on the kind of alloy. But steel generally, all of steel is aluminum. So one thing to consider or read up on specifically what alloy you're using before you're welding anything. And some alloys are more brittle, like the 6000 alloys are, you can weld them, but then because of their brittle nature, they're gonna be prone to cracking. Um, I just mentioned all of this earlier. If you ever see the sign TIG or the acronym TIG, it's tungsten inert gas welding. It's the most common form of welding. Um, and I believe there's one available for EPICS. Um, but yeah, the other kind of rookie mistake that happens a lot is when students try to weld two different metals together. Um, Generally, that's hard to achieve because of different melting points. So when one starts melting, does not necessarily mean it's going to melt and bond with the other one. Um, so yeah, it's not something that's advisable. Very few people or can do it. You may even need special equipment. So always make sure that you're welding similar materials. And finally, or almost finally, I'm going to talk about plastics and what options you have with plastics. What you're going to be seeing a lot of, or you've already been seeing a lot of, is acrylic. This is a picture that's a sneeze shield or cough shield, whatever those are, where you see in front of lecture halls. Um, but they're transparent, UV resistant, they're very strong, but then they can be brittle, they'll break easily. We have a laser cutting machine downstairs. So if ever you have to cut sheets of glass, no, or sheets of acrylic, um, know that that's easily done within EPICS. And polycarbonate is an option if you're looking for something that's more durable. It's not going to be as transparent um, because, well, it starts out transparent, but then it kind of, it's not robust to UV light, like I put here. You can tell it's going to get more and more foggy with time. But it's more robust, as in like mechanically more sound than acrylic. Um, a use case, a popular use case for polycarbonate is for like window. The Corec, I believe, has polycarbonate. And then, so you have other plastics you can consider are Delrin and Teflon. Um, Generally, they're very easily machined. You can use whatever we have downstairs to easily machine them. Delrin is known to be smooth. Like I put a picture of a gear. It chooses a gear because it has very low friction. And then, yeah, ceramics are generally not used, but then I just wanted to put them out there as um, an option. They're only ever used when you're in need of an insulator of a specific temperature capability, and as well also dielectric strength. So only in those situations you would ever consider ceramics. But if you're trying to machine ceramics, it's not gonna be easy. You're not gonna be able to do it anywhere on campus. And then you have finally is the high performance composites. The more common and accessible one is fiberglass. You're gonna see FR4 fiberglass, epoxy, whatever. I think there's even blocks of fiberglass downstairs that someone left behind. Uh, it's what circuit boards are made of. The breadboards. Um, Dust can be hazardous just because it's so fine, but then it's strong, but also a little brittle. And then finally, you have carbon fiber. Carbon fiber is used generally when you need something very strong, but then also very light. Um, I put an example of something that's made of carbon fiber is helmets um, for motorcycles. You also have a lot of the dashboard within your car that is made of carbon fiber. Um, as far as machining carbon fiber, you can order it in sheets or tubes, and those can always be cut. So, I know it's just like a lot of information dump, but then again, the one key thing to consider to keep in mind is what are you going to consider in your design in picking your material? So with like for each of your project, you can go back and reflect on this is when would, again, to touch base on this again, is when would you need to manufacture? What part of your design would affect your manufacturing and vice versa? Um, and then finally, again, what considerations are you going to make in selecting your materials? So that is all I have. I am going to stop recording at this point.